Hi everyone, and welcome to this lecture on cost surfaces using row column distances. A cost surface is a raster in which the value in each cell is the cost to travel to that cell from a source. Cost can be measured in time, money, energy, carbon emissions, or any other measure. Computing cost surfaces using row column distance is actually quite easy, but there's a few key things to know. The first is that the cost for every cell is going to equal the row column distance traveled within that cell times the friction of that cell. So you need a friction surface that represents those costs. So that could be the money to travel through a cell, or calories consumed, or carbon emissions, whatever your costs may be. And then you also need to know the distance of each cell. You can figure out the distance through the resolution. In this example, the resolution down here is 10 meters. That means every cell in the raster is 10 meters from edge to edge. So as you're computing your costs, if we're going to start up here in the source cell, and our goal is to make it over here to the cell labeled number 2, we need to compute the cost to travel through every single cell on the route. So starting in the source cell, we only have to travel halfway across that cell since we're starting in the middle. If the resolution of the raster is 10 meters, that means the distance to travel through that first cell is only 5 meters. So our cost to travel through the first cell is 5 times the friction, which is 1. The next cell we enter is the one next door, and similarly, we're going to compute the cost to travel through that cell. Now the cost this time as we're traveling is going to be 5 times 1, which will get us from the edge of the cell into the center. And then we need to turn south and travel another half of the cell, so another 5 meters times the friction, which is 1. That gets us to the edge of the middle cell with the friction of 3. And again, we're going to travel 5 meters to the center, so 5 times a friction of 3. And then turn west and travel another 5 meters times a friction of 3. Lastly, we need to travel the last bit into the destination cell. So we'll travel 5 meters times a friction of 2. And what we do is we add up all of those values to get the total cost that it takes to travel from the source cell to the destination. In this case, our cost is simply all of those values that we added up. So 1 times 5 plus 1 times 5, and so on and so forth. And if we add up all of those numbers, the total cost it took us to get to that destination cell was 55. So in our output cost surface, the new value for this cell is 55, because that is the cost it takes to travel to that cell from the source cell. So that's it for cost surfaces. There are a couple practices that will help you learn how to compute row column cost surface distances on your own. Straight line distances are different, and we will go over those in another lecture. See you next time.